Welcome back. Today we'll look at hardware breakpoints and memory patching. First, some definitions. What is the difference between hardware breakpoints and software breakpoints? Hardware breakpoints are breakpoints on memory addresses. It means we set a breakpoint on the location which is in the RAM memory itself, so that we can keep track of which process or which instruction is accessing those RAM memory locations. On the other hand, software breakpoints are breakpoints on the instructions itself. So that's the difference between the two. So in today's lesson, the objectives are as follows. First, we are going to learn how to set hardware breakpoints on RAM memory. And number two, we are going to learn how to modify data in RAM memory addresses directly. So let's get started. Open the CrackMe with x64dbg. Make sure your option preferences are set as follows. Uncheck system breakpoint and TLS callbacks, and make sure that your exceptions are ignored. Note that you are now at the entry point, and let's run the program by clicking Run button or F9 on the keyboard. Immediately the program opens and it has already detected that it is unregistered. So the objective is to find the memory address location where this unregistered is being accessed to determine whether it's unregistered. And so you should find the correct address to patch to make this software become registered. So we are going to use the first method to search, which is to search for strings. We'll be looking for this string to see where it is being used in the instruction. So let's right click, search for current module, or another way is, let me show you another way. You can also do this. To make sure you're in the correct user module and not in the system module, you can either make sure you are in the breakpoint, the correct offset, by comparing it with the detect easy offset address which we did earlier, or we can go to the symbols tab and directly click on CrackMe here, and you can see here the base address. You can directly click on that. So now you can be sure that you are in the user module space. You can start looking for strings. So right click, search for current module, string references. Let it do its search. We are looking for this string here, unregistered. And now it has finished searching. If the list is too long, you can just search it in the search box here. But the list in this case is quite not that long, and we already saw the result here, unregistered. And above it is registered. Interesting. So let's go to this address, unregistered, double clicking it to go to the assembler. So over here, we see the string unregistered, and just above it is registered. So this is the string, the bad message. This is a string for the good message. And how do we know which one will be shown? So you should look for a jump. Up here there's a jump. So the jump is the one which decides whether it will show this or this message. So we should put a breakpoint here and then restart. Run to our breakpoint, and now you can see we are at the breakpoint and it is showing red, meaning that jump is taken. So it will jump over the good message and go into the bad message to show this bad message here. So now our objective is to analyze and try to make it not jump. So we don't want it to jump. So it shouldn't jump. Previously, what we did was we just modify this by putting no op like this, and then it won't jump. But in today's lesson, I'm going to show you another way. Instead of doing this, we are going to modify the memory location where the comparison is being made somewhere up here. Now, every time we see a jump instruction, it is testing the flags. In this case, JE means it will jump if the zero flag is 1. So JE means jump equal, means if equal to 1. So in this case, the zero flag is 1. That's why it's jumping. And earlier lessons, we learned how to toggle this flag by double clicking it to set it to the opposite. And now you see it is not going to jump. But like I said, we are not going to use this method now. We are going to use the memory patching method. So in order to find out where the zero flag is being set, we should look for either a compare or a test. So let's look for this. Either a compare or a test. Whenever there is a jump, you can be sure that just before it, somewhere nearby, there will be a compare or a test. So like for example, there's a test here, then there is a jump. So the test here will set the flag, zero flag to 1 or 0, and then the jump will look at the zero flag to decide whether to jump or not. Same thing here. Whenever there's a jump, just above it, there will be a test or a compare. So in this case, it is a compare. So this comparison here sets the zero flag either to 1 or 0. So in this case here, the zero flag is set to 1. When you see zero flag is set to 1, it means that whatever is being compared is same. This memory address is being compared to 0. So if they are the same, then zero flag is set to 1. If they are not the same, then zero flag is set to 0. So in this case, zero flag is set to 1. We can confirm it by putting a breakpoint here, or maybe just before it, and remove this breakpoint, then reset. Now we jump to a breakpoint, and the next instruction will compare these two. So let's press F8. So now it is about to compare these two. And what happened to the zero flag when I press F8? It is 1, yes. So that means that whatever is in this memory location is also 0. That is why this zero flag is set to 1. So this is the memory location that we need to put a breakpoint on if we want to observe it. So just click on this memory location, and then you will come here, select this memory location, right click, follow in dump, and then select the address. So your address might be different from mine, but whatever it is, the address here should be this address listed here, which is this. So just right click on this, follow in dump, address, and then it will jump here. So you can see the address here, for my case now is 7260D0, is referring to this address. So in this address, there is stored a data, some value, a byte, which is at the moment 0. So you see, it is comparing this 0 with this 0. So in this case, 0 compares with 0 is true. So when it is true, it is the same it means it's the same, then it will set the 0 flag to 1. If this was 1, let's say you are comparing 1 with 0, then the comparison will be false and the 0 flag is 0. It will not be 1. The 0 flag will only be 1 if this is 1 and this is 1, or this is 0 and this is 0. In other words, both must be the same. It can be 10 and 10, 20 and 20, or 30 and 30, whatever. As long as they're the same, the 0 flag will be 1. So in this case, it is the same, 0. That is why the 0 flag is set to 1. So because the 0 flag is set to 1, when it comes to this line, the jump will take place. See, it's going to jump because the 0 flag is set to 1. So what we need to do now is to put a breakpoint here just to demonstrate to you that indeed we can set breakpoint. Actually, to set a breakpoint, we just right click here and then go up to breakpoint, hardware access, byte, word or dword, either one. So byte means you want to set a breakpoint on only 1 byte. Word is 2 bytes. Dword is 4 bytes. So this is 1 byte, and then this is word, and this is dword. So it's either 1, 2, 1, 2, or 4, like this. Okay, so at the moment you can choose any one. So to set a dword, breakpoint on dword, you just click like this, right click, breakpoint, hardware access, dword. So dword is 4 bytes, word is 2 bytes, and this is 1 byte. So we are going to set a breakpoint on dword. So you're watching this 4 bytes here, dword. So now we are going to remove both breakpoints, this breakpoint and this breakpoint. We need to remove. If you don't remove the breakpoints, it will interfere with your hardware breakpoint. So let's reset and run. And now you see we have hit the hardware breakpoint at this address. So we can just go directly to this address here, by clicking this one, right click, and you can go to follow in dump, this address. So there we go. Another way is you can click on this line, and then from here right click, follow in dump address, and there you go. See, so the breakpoint has been hit. Alright, so now we can press F8 to step over it, like this. Okay? Alright, so now we know that this is the location where the memory is being read, to compare whatever is stored in this location with this 0. So if we want to modify the code, modify the memory so that we change this to any number other than 0, we can do it here. Now the one way in which you can do it is, now before that, why would you want to modify this to any number other than 0? For example, we can put this as 1. Why do we do that? We do that so that this comparison will fail. So when it fails, the 0 flag will be 0. And when the 0 flag is 0, this jump will not be taken. That's the whole idea. Alright, so let us put a breakpoint before this thing, a software breakpoint, just for testing. So we put a software breakpoint before this, and now we restart and run to our software breakpoint. And now the next step is it is going to read this memory address. But before it does that, let us modify the data stored here. So to modify that, we click on this, come here, right click, follow in dump, this address. So let's change this to 1. So we can right click. How do we modify a memory directly? We can modify the memory directly by selecting the the part of the memory we want to modify. In this case, we want to modify only this 1 byte here, so that we can change it to 1. We can right click this, go to binary, edit, and then here check on the keep size, because we don't want to overwrite the next bytes. So we just click here and change this to 01. Type in 01 like that, 01, and then click OK. And now watch what happens here. So we have modified this data in memory itself directly. So now it is going to, when we press F8, it is going to go there and compare 01 with 0. And guess what will happen? What do you think will happen with the 0 flag? Let's try. So we're going to press F8. Now we are going to press F8 again so that you execute it, and watch 0 flag. 0 flag is 0. Earlier on it was 1. So you see, compare takes whatever is stored in this memory, which is 01, and compare with 0. And then because 01 and 0 is not the same, therefore the comparison fails. So the 0 flag is not set to 1. So this is how it works, right? So now if we just press F8 to keep on going, it is not going to jump. See this? It is gray. Gray arrow means not going to jump. So you press F8 again, and you just go right ahead to show you the good message. So what we have just done is to crack the software to make it become registered by modifying the memory directly over here. This is called memory, cracking the memory directly. Alright, so what remains, okay, now if you were to continue to press F8 and so on and on, eventually it will just pop up the window to show you that it is registered. There you go, registered, right? So now we need to patch this to make it permanent, because if we restart again, this memory will reset to this 0 value. So to make it permanent, we patch it, file, patch file, and there's one thing to be patched. So click patch file and give it a new name, patch, click save, click OK. Right, so now we can open the patch file and run it, and it's registered. So this is how we do memory patching. We analyze the memory first by putting hardware breakpoints, then we test our theory whether it's correct to patch that memory address, and if it's correct, we can go ahead and patch and we see it works. So thank you for watching. I'll see you in the next one.